Welcome to my AI newsfeed, 2020-60530. Today's 6 stories. Story 1, Anthropic can now track the bizarre inner workings of a large language model. Story 2, can large language models figure out the real world? New metric introduced. Story 3, AI News Today, May 24, 2026, 11 biggest stories. Story 4, do large language models have an English accent? Evaluating and improving the naturalness of multilingual LLMs. Story 5, the homogenizing effect of large language models on human expression. Story 6, OWASP Top 10 for large language model applications. Imagine asking an AI assistant a question in French and receiving a response that is technically correct, but feels strangely foreign, like it was written by someone who thinks in English and translated on the fly. That is exactly the phenomenon a team of researchers tackled in a paper presented at the 2025 annual meeting of the Association for Computational Linguistics in Vienna. The paper, authored by Yanju Guo, Simone Kania, and colleagues, asks a deceptively simple question. Do large language models have an English accent? The answer, it turns out, is yes. Even the most capable multilingual AI models today tend to generate text in non-English languages that reflects English-centric vocabulary choices and grammatical structures. The researchers compared this to how second language learners often produce awkward expressions that betray the influence of their native tongue. For AI systems trained predominantly on English data, that native tongue is always English, regardless of what language they are asked to speak. To study this rigorously, the team developed new automatic metrics designed to measure lexical and syntactic naturalness at the corpus level. They then built a benchmark covering French and Chinese, two languages with very different structural relationships to English, and ran evaluations on state-of-the-art language models. The results confirmed a consistent pattern of English-influenced outputs across both languages. But the paper does not stop at diagnosis. The researchers also proposed a practical alignment method that can be applied to improve naturalness in a specific target language and domain. Crucially, this improvement comes without any degradation in the model's performance on standard general-purpose benchmarks, meaning organizations can adopt the fix without sacrificing overall capability. Why does this matter? As AI tools become embedded in education, customer service, legal systems, and media across the globe, the linguistic authenticity of their outputs becomes a question of equity and trust. Millions of French and Chinese speakers deserve AI that sounds like it belongs in their language, not like a translation. This research provides both the tools to measure that gap and a path to close it, marking an important step toward genuinely multilingual artificial intelligence. One of the quieter but potentially most consequential concerns about large language models is not about hallucinations or bias in the traditional sense. It is about sameness. A preprint circulating in research communities and highlighted by the well-regarded curation site Gwern asks a pointed question. Are LLMs making human expression more uniform, flattening the rich diversity of how people write, think, and communicate? The paper, authored by Sawarati and colleagues, examines what researchers are calling the homogenizing effect of large language models on human expression. The argument goes like this. When millions of people use the same small set of AI systems to draft their emails, essays, academic papers, and creative work, those outputs inevitably converge toward the statistical average of what the model was trained to produce. Individual voice, regional style, cultural rhetorical tradition, and idiosyncratic ways of thinking get smoothed out in favor of competent, generic, safe prose. What makes this particularly concerning is the feedback loop it creates. As AI-assisted text floods online platforms and publishing ecosystems, the training data for the next generation of models becomes increasingly composed of this homogenized content. Each new model may therefore amplify the effect rather than correct it. The paper is categorized under research on the illusion of depth, a cognitive bias in which people mistake fluent, well-structured language for deep thinking. This framing suggests the researchers are worried not just about stylistic uniformity, but about a subtler epistemic problem, AI-assisted writing that looks thoughtful but reflects shallower intellectual engagement. The implications span academia, creative industries, and public discourse. If unconventional arguments, minority dialects, and culturally specific rhetorical styles are increasingly filtered out by AI writing tools, we may be building a future in which the full spectrum of human thought is less visible in the written record. For educators, publishers, and platform designers, this research raises urgent questions about how to preserve authentic human voice in an era when AI can produce passable prose on demand. When developers and security teams ask what they need to worry about most when building applications on top of large language models, there is now a widely accepted answer: the OWASP Top 10 for Large Language Model Applications. Produced by the Open Worldwide Application Security Project, the same organization behind the foundational web security framework used across the industry for decades. This list has become the go-to reference for AI application security since its launch in 2023. What started as a small working group of security professionals responding to an urgent and largely unaddressed gap has grown into something much larger. Today, the project counts over 600 contributing experts from more than 18 countries, with nearly 8,000 active community members collaborating through regular meetings, working groups, and open contribution channels. It has also expanded in scope, evolving from a focused top 10 list into the comprehensive OWASP GenAI Security Project, which now covers not just LLM APIs, but agentic AI systems and AI-driven applications more broadly. At the top of the vulnerability list sits prompt injection, which describes how attackers can manipulate LLMs by crafting inputs that override the model's intended behavior, potentially leading to unauthorized access, data breaches, or compromised decision-making. Unlike traditional code injection, attacks that exploit syntactic parsing, prompt injection exploits the model's own reasoning, making it uniquely difficult to defend against with conventional input validation. The second critical vulnerability, insecure output handling, addresses a related problem. When LLM outputs are fed directly into downstream systems, databases, code interpreters, APIs, without proper validation, the outputs themselves become an attack vector. The expansion to cover agentic AI is particularly timely, as LLMs are increasingly given tools, memory, and the ability to act in the world. Browsing the web, executing code, sending emails, the attack surface grows dramatically. An agent that can be manipulated through adversarial inputs in its environment is a fundamentally different risk than a chatbot. For any organization building on generative AI today, the OWASP framework is not optional reading. It is the baseline. Published at ACL 2025, this research paper investigates whether LLMs produce outputs that feel unnatural in non-English languages due to English-centric training data. The authors propose evaluation methods and improvements to increase multilingual naturalness in LLM outputs. This is relevant for global deployment of LLMs and understanding model bias. This research examines how widespread LLM use may homogenize human writing and expression, with evidence from studies including 30,000 college admissions essays. The paper also references findings that LLMs can misportray identity groups when used as substitutes for human research participants. It raises important concerns about the societal and alignment implications of LLM integration. The OWASP Foundation's ongoing project documents the top 10 security risks associated with deploying and managing LLM-based applications. It serves as a practical reference for developers, architects, and organizations building on top of LLMs. The resource is regularly updated and highly relevant for anyone implementing AI systems in production.